Okay, now we're going to start on Chapter 9, Section 4, or Section 2, excuse me, which starts with problem number 25. Okay, and these are all solved by elimination. So we have 2x minus y is equal to 2, and 6x plus 8y is equal to 39. Alright, so we can do this a couple different ways. It really doesn't matter. Since that's already a negative y, I'll multiply the top one by 8. And when I do that, I get 16x minus 8y is equal to 16. I add those together. I get 22x is equal to 56. 49, yeah, 56, 55, excuse me. All right, and then 16 plus 6, yeah, and okay. So x is equal to 55 over 22. Both of those divisible by 11, so 5 halves. X is equal to 5 halves. So I do 2 times 5 halves minus y is equal to 2. 5 minus y is equal to 2. So y is equal to 3. And so my solution is the point 5 halves, 3. Okay, 27. 27 is 0.2x plus 0.3y is equal to 0.14, and 0.4x plus 0.5y is equal to 0.20. Alright, so again, elimination. We can work with the decimals. We can not work with the decimals. I'm not going to work with the decimals, so I'm going to multiply everything by 100. Get this and this. I'm going to take my top equation and multiply it by negative 2. When I do that, I'll get negative 40x minus 60y is equal to negative 28. Alright, and I still have 40x plus 50y is equal to 20. Remember that comes from that one's there, and that one's there. Okay, so we do that addition. And when we do that, the x's cancel. We get negative 10y, and we get negative 8. So y is equal to 8 tenths, or 4/5, or if you prefer 0.8. Any of those is acceptable. All right, I'll use 4/5. I will take, let's take this equation. All right, and so I get 40x plus 50 times 4/5 equals 20. So I'll get 40x plus 40 is equal to 20. I get 40x is equal to 1/2, or should I, negative 20. So I get x is equal to negative 20 over 40, which is equal to negative 1/2. So my solution is negative 1/2 4/5. Moving on to 29. '29 says 3x minus 2y is equal to 0. It also says that 3x plus 2 times y plus 5 is equal to 10. Okay, so I'm going to take this top equation, and since I have a 3x here and a 3x here, I'm going to rewrite that as 3x is equal to 2y. And so instead of 3x, I can write 2y, and then multiply the 2 in. So I get 4y is equal to 0, or y is equal to 0. right? If y is equal to 0, that means 3x equals 2 times 0, or x is equal to 0. So my solution is 0, 0. And 31. Is 1.25x minus 2y is equal to 3.5. And then 5x minus 8y is equal to 14. Okay, you have options. I'm going to multiply this one by 4. And when I do that, we'll note that I get 5x minus 8y is equal to 14. And those are the same. All right, which means it's dependent which means infinite solutions. And if you were going to write it with a variable, okay, we would do something like if x is a, what's y equal to? And if x is a, y is equal to 14 minus 5a over negative 8. Okay, it's 31. Next ones are labeling for graphing, matching graphs of systems. So for 33, I have the system x plus 5y is equal to 4, and x minus 3y is equal to 6. So we want to describe the system linear equation with this graph, describe the number of solutions, and state whether the system is consistent or inconsistent. All right, so x is equal to 5, or x plus 5y. So if I want to look at the graphs, I'll just write y. Okay, get y by itself. So that is y is equal to negative 4/5 x plus 4/5, and that's y is equal to 1/3 x minus 2. So looking at those graphs, looks like D is my option. Okay, D, which is my option, which means it has one solution. And it means it's consistent because it has a solution. Looking at 35. 35. 35 says 3x minus y, y equals 7. And 6x plus 2y is equal to 8. Again, easiest way to graph it is put slope-intercept form, which says y is equal to 3x minus 7. And that says y is equal to negative 3x plus 4. Okay, so looking at those two equations, did I copy the problem down wrong? Oh, yeah, I copied the problem down wrong. Negative 6, which makes that a positive 3x minus 4. All right, so the same slope, different y-intercepts means they're parallel. Okay, so parallel lines would be option B. which means there are no solutions because they don't cross. No solutions, and then it's inconsistent because it has no solutions. All right, let's do 37. We've got a two equations. We want to know where they balance. Okay, we want to know the supply equation and a demand equation. Okay, so to figure out the equilibrium point, we set them equal to each other. So that's what I'll do. I get 37 minus 0.0002x is equal to 22 plus 0.00001x. And so I subtract the 22 and I get 15. Add the 0.0002x and I get 0.00021x. If I add those together and then divide 15, so second quit, divide 15 divided by 0.00021, and we get x is equal to 71428.58. Doesn't tell me what x represents. So that's the equilibrium point. That's the x for that. And so if I plug that back in for P, okay, either equation. So we multiply that number x times 0.11, and then I add that to 22, and I get a price point of 22.71. All right, that's the end of 9.2, so we'll pick up 9.3 on the next video.